Abrasive machining is a material removal by the action of the hard abrasive particles, usually in the form of the bonded wheels. Generally, it's going to be used as a finishing operations after the part geometry has been established by the conventional machining. The grinding is the most important abrasive process, and the other abrasive processes like the honing, lapping, super finishing, polishing, and the buffing also may apply. Main advantage of the abrasive machining are it can be used on all types of the materials. Some can produce extremely fine surface finishes, and some can hold dimensions to extremely close tolerances. Grinding is a material removal process in which the abrasive particles are contained in a bonded grinding wheel that operates at very high speed. The grinding wheel is usually disc-shaped and preciously balanced for the high operational speed. The grinding wheel consists of an abrasive particles and bonding materials. The abrasive particles accomplish the cutting, while the bonding materials hold the particles in place and establish the shape and the structure. The grinding wheel parameters are the abrasive materials, the grain size, the bonding materials, the wheel grades, and the wheel structure. Different abrasive materials are appropriate for the grinding different work materials. Generally, the properties of the abrasive materials used in the grinding wheels include the high hardness, the wheel resistance, the toughness, and the friability. The friability is the capacity of fracture when the cutting edge dulls, so new sharp edges are going to be exposed. The grain size of the abrasive particle is important in determining the surface finish and the material removal rate. The smaller grit, where the sizes produce a better surface finishing. With the larger grit, the size permits larger material removal rate, and the harder work, where materials require smaller grain size to cut effectively, and for the softer materials, require a larger grit size. The grit size is measured using the screen measure procedure. In this procedure, a smaller grit size have a larger number and vice versa. The grain sizes used in the grinding wheels typically range between 8 and 250. The grit size 8 is very coarse and the size 250 is very fine. Even finer grit sizes are used for the lapping and the silver finishing operations. Smaller grit sizes produce better finishes, and larger grit sizes permit for a larger material removal rate, and the harder work materials require smaller grain sizes to cut effectively, and finally softer materials require larger grit sizes. The bonding materials hold the abrasive grains and establish the shape and the structure integrity of the grinding wheel. It must withstand the centrifugal forces and high temperatures, also must resist the shattering during the shock loading of the wheel. Finally, it must hold the abrasive grains rigidly in place for cutting, yet to allow the worn grains to be dislodged to expose new sharp grains. The wheel structure refers to the relative spacing of the abrasive grains in the wheel. In addition, the abrasive grains and the bond materials grinding wheels contain air gaps or pores. The volumetric proportions of the grains, the bond materials, and the pores can be expressed with the following equation, where the PB is the proportion of the bond materials, and the PP is the proportion of the pores, and the PG is the proportion of the abrasive grains in the total wheel volume. The wheel structure is measured in the scale that ranges between open and dense. An open structure is one in which the porous percentage is going to be relatively large and the grain percentage is going to be relatively small. That is, there are more pores and fewer grains by the unit volume in the wheel of the open structure. Dense structure means that the PP is going to be relatively small and the PG is going to be larger. Thus, we are going to get better surface finishing and better dimensional control. The wheel grade indicates the bond strength in retaining the abrasive grains during the cutting operation. This will depend on the amount of the bonding materials in the wheel. It's measured in a scale from soft to hard. The soft wheels will lose the grain readily and used for the low materials removal rates and the hard work materials. The hard wheels will retain the grains and used for the high stock removal rates and the soft work materials. The protein parameters can be consistently designated in a standard grinding wheel, making the system defined by the standard organizations. This marking system uses numbers and letters to specify the abrasive type, the grit size, the grade, structure, and the bond material. The grinding wheels comes in a variety of shapes and sizes. Some configurations are peripheral grinding wheels, in which the material removal is accomplished by the outside circumference of the wheel. A typical abrasive cut-off wheel is shown, which also involves the peripheral cutting. Other configurations are the face grinding wheels, in which the flat face of the wheel removes the materials from the work surface.